Hi, everybody. Hope you are all doing well. This will be our first lesson here since we have not been at school. This will be due to the coronavirus, so I hope you're all staying well, staying healthy, and also staying upbeat. No, it's not easy being stuck at home all the time, but we're all in it together. We're all having the same experience. So here we go. First lesson that we're going to be doing is exponential functions and exponential growth. So an exponential function is just a function where x is in the exponent spot. That's really all it is. It sounds kind of complicated. An exponential function, what's that? Nothing crazy. A function where x is in the exponent spot. That's it. Okay. If x is not in the exponent spot, then it is not an exponential function. All right. And this is the most basic version that we could write the equation for this function. The parent function is this uh, b with x in the exponent spot. So b is just any random number, 2, 3, 5, -12, whatever. B is b, it's a number, and x is up here in the exponent spot. And this is the most basic version of one of these equations that you can have. And we're going to look at what one of these looks like and then build on that a little bit. So if we look at the examples here, the first one, f of x equals -4 to the x plus 12. So this is an example of an exponential function because x is in the exponent spot right there. There it is. X is in the exponent spot, so it's an exponential function. If we look at this other example, g of x equals 8 minus 3x to the fourth. Well, that one is not an exponential function because x is not in the exponent spot. There's x. X has its own exponent, but it's not in the x. It's not the little letter. X is the big letter down here. It's not in the exponent spot, so it is not an exponential function. So let's talk about what an exponential graph looks like. So this is the function that we're going to graph right here. It's f of x equals 2 with x in the exponent spot. Okay, so I've got made a table here. These are all the x's that we're going to plug in. We're going to plug in -3, -2, -1, 0, 1, 2, and 3. One at a time, plug those into 2 to the x, okay, and see what we get. I've done that already. Here are those numbers right here. If you plug in 0, you get 1 because any number with 0 in the exponent spot, any number with 0 in the exponent spot is going to be 1 every single time, okay? And then you got 2 to the first power, that should be 2. 2 squared, 2 goes in the exponent spot, so 2 squared is 4. And then lastly, 3, you put 3 in the exponent spot, 2 to the third power, that's 2 times 2 times 2, that's 8. Okay, so I calculated all of these for you. So of course you're always going to be welcome at this point because you're all home to use your phone as calculators. What I would do to make sure you are really good with using your phone calculator is take these numbers, these x's, plug them into this and this equation, plug those into your phone, and make sure you can get these numbers that I've got here. Okay, so we've got some points we can plot. Here's our graph. We're just going to take each one of these points and make it a dot on our graph. Okay, and there they are. The first one, -3, we're barely off 0. So -3, just up a little bit. -2, only 0.25, so just up a little bit more. And then you get the last one at 3, we're up 8. So here's 3, up 8. Just put all the points on the graph. That's all we did there. Okay, so now I'm going to connect these dots to give this graph some shape. And it's going to kind of look like this, okay, this curvy thing. And so the next thing I'm going to talk about is not use any fancy technical math terms. We're just going to kind of say, what does this, let's look at the shape of this. What is the shape, okay? So first off, it starts out pretty flat, right? The very beginning of it is really flat. And then what happens? Then it starts to grow, and it starts to grow up and up and up. At first it grows a little bit, right? But then it starts to grow a lot, right? First it grows a little bit, and now by the end of it, it's going up really, really fast, right? And we can see that in the numbers too. 0.125, very little, and then we went up to just 0.25. That's only a little jump, and then 0.25 to 0.5, bigger jump, but still little. And then our jumps get bigger and bigger and bigger from 1 to 2, 2 to 4, 4 to 8. Now we're going up real slow at first, and then all of a sudden we're going up real fast. Okay. This is kind of interesting that this is what we're covering right now. This is what was lined up in our textbook to come next, because this is exactly why people are concerned about the coronavirus, is because the coronavirus follows this kind of curve right here. At first it grows like, it's not a big deal, right? It's not. There's only a couple of them, and then all of a sudden it's like, okay, now there's getting to be a lot, and then all of a sudden it just kind of makes this really big jump, starts making these really big jumps. And so kind of interesting that this is relevant actually to exactly what is happening right now and why it's all important for us to kind of stay at home. All right. So we can plug any number in for x. If you look at this equation, like we all know we can't divide by 0, right? But there's no dividing here. So we can put any number here where the x is. And so what does that mean? Well, that means our domain is all real numbers. Remember, domain is all the things that we can plug in, all the different numbers, not just a couple of them. We want to talk about all the numbers that we can plug in, but we can plug in anything we want. So the domain is all real numbers. And of course, if we're going to talk about domain, that's the x's. We're going to talk about the y's, which we call range. Let's kind of look at what's going on. The graph goes up and up forever, right? It's going up, going up, going up, and it will keep going up forever. But not down, right? If we look at this side, it starts to get more and more flat, right? It's getting flat, it gets flat. It doesn't go down and down, down forever. So on that left side, the graph is getting closer and closer to 0, but never actually seems to get there, right? It's still, no matter what, even right here, it's really close, but it's not actually at 0, okay? So that means that our range is all numbers, but we're using f of x here because we're talking about the f of x numbers and the y part of the graph. They're always those y numbers, and you can see it right here in the table, right? They're always, all of them, every single number up here on the bottom part of our table, they're all bigger than 0, right? They're all greater than 0, and that's all this is trying to say right here. Our range, all of our outputs are bigger than 0. Range is outputs, that's y. That's on the graph, okay? So next thing we're talking about, right, this is kind of weird. It's getting close to 0. So we have that's a thing, okay? And we're going to talk about what that thing is. Okay, so y equals 0. This red line right here seems to be a boundary line for the graph, right? This is a boundary. The graph does not go across this line. It doesn't even get to the line. It can get as close as it wants, but never actually go over it, okay? So anytime a graph has a boundary line, we call that boundary line an asymptote. So if you get a question, what is an asymptote? It's just a boundary line. That's all it is, okay? It's just a boundary line. It's kind of a funky looking word. It looks like challenging, like, oh, that's a crazy word, I got to remember that. Like, it's just a boundary line. That's it. This red line right here. That's all it is, okay? So this is what an exponential graph looks like. We're just kind of talking about what it is, where does it come from. We got plugged in some numbers and started talking about what it looks like. It starts out flat and then starts to grow, and then it grows faster and faster and faster. All right, so let's talk about general form of these kinds of functions. So we talked about the parent function this is the easiest one, right? Just a number with x in the exponent spot. Just a number with x in the exponent spot. Okay, so what's the biggest one we can look at? The general form is going to look like this. Now the x isn't by itself, it's got a little friend h. So we got x plus, not just x up here in the exponent is x plus h. We've also got this a out front, so we're going to multiply by a in the very, very front. And what else did we add here? We added a k. We added k at the very end. This is all kind of tied together. You do all this stuff, and then at the very end, kind of like an afterthought, like, oh, yep, can't forget to do that. We got a plus k. So what do each of these letters do? Let's see it. Let's take a look. So this is Desmos.com, by the way. This is something that's totally free. So if you guys are needing to try and look at some graphs and see what they look like, you can use this, absolutely. The typing is pretty easy to do exponents. You use the little up arrow caret type looking thing on your keyboard, or your keyboard, and you can get this exponent like this. It types in pretty simply, just kind of like how you read it. All right, so I made B2 again, just like the first graph. So this is actually the same exact graph that we just made. Okay, the same exact one. But now we've got this K, the H, which are both 0, so they're not doing anything right now. There's our k, there's a h, but it's basically like they're not there because right now they're just 0. And then we've got a in front, which I've got set to 1 because what's 1 times 5? Well, that's 5, right? You can kind of ignore it. That when you multiply, you can ignore a 1. So this is the same graph we already looked at. So let's first talk about k. K is over here on the end. What's going to happen if I change k? And some of you might know exactly what these three things are going to do because we have talked about and actually used the same letters for other different kinds of functions that we've talked about, like quadratics and whatnot. We've seen this kind of stuff before. So if I make k bigger, which is what I'm going to do, right now it's 0, I'm going to make k bigger, and let's look at what happens to the graph. Slowly, just a little bit at a time, a little bit more, making k bigger, making k bigger, making k bigger. What's happening to the graph? The shape isn't changing, but it's sliding up. It's going up. And so let's see what happens if I make k smaller. Instead of making k bigger, I'm making k smaller, and now it's going down, right? And if I make it negative, it keeps going down, just keeps going down, down. The smaller I make k, the more down the graph goes. So we can add that to our notes over here. K is a vertical slide. This k, it's going to slide the graph up or down. All right, so now let's next talk about h. What is h going to do to this thing? Right now h is 0, so you can imagine k is being added down here, h is being added up here by the x. They're both being added just in different places. So if k made the graph go up and down, let's see, what is h going to do? If I change h, what is that doing? Okay, now instead of sliding up and down, now the graph is sliding left and right. So instead of sliding it vertically, now we're sliding it horizontally. Something kind of strange though, right? If I make h bigger, the graph actually goes to the left. That's kind of strange, but it is what it is. If I make h smaller, then the graph goes to the right. So we can add this to I'm going to set it back to 0. We can go back to our notes here. So h is a horizontal slide. It slides the graph left to right or right. And h does the opposite of what you think. If it's positive, then the graph will go left. It's kind of weird. And, of course, if you make h negative, then it's going to go to the right. So kind of strange, but it is what it is. But we saw it for ourselves, and so we know what's going to happen. All right, now let's talk about a. What is a going to do? Now a is being multiplied. We're not adding h. We're not adding a. We're multiplying a. So let's see what happens if we make a bigger. Okay, so it kind of looks like the graph, I'm going to be honest, looks like the graph is sliding left, but that's not really what's happening. Because if you notice, it should be going, it's actually getting steeper. Like, what if I make a really big? Let's make a 10. It's going up faster and faster and faster. That's really what's happening here. Let's see if I zoom out, if we can see this. Okay, so if we make a smaller, notice when we go put it at 0, right? Now everything's 0, and so we just get a flat line at 0. But the bigger you make a, see how nothing's really happening over here, but it's tightening this line against the y-axis. So that's kind of showing you it's not sliding, it's stretching it up. It's really grabbing this line and pulling it towards the y-axis. So a little bit tricky to see if you're not looking far enough out, but that is exactly what's actually happening. Yeah. A stretches the graph if it's greater than 1, and A squishes it if the graph is between 0 and 1. Okay, something else about A, really quickly. What if we make A negative? All the A's that I tried, those were all negative. Those were all positive. What if we make A negative? And as some of you might be able to guess, if you make a negative, instead of going up, what's going to happen? Well, now we're going to go down. So add that here. A flips the graph down if it's negative. So something really interesting here. What if B is 1? This is a very, it seems like, well, a really specific and weird question to ask, but we're going to ask it. What happens if B is 1? We talked about A and AH and K. What happens if B is 1? Okay, so here's the regular equation. All I did was take this same equation and copy it down here. That's it. Okay, and I put 1 where B is. Here's B. I put 1 where B is. What if B is 1? Well, let's make B 1. Well, the weird thing about that, right? What's 1 to the 10th power? It's 1. What's 1 to the 15th power? It's 1. What's 1 to the 300th power? It's 1. It doesn't matter what exponent you put on 1, because 1 times 1 is 1. Times 1 times 1 times 1 times 1 times 1 is 1. Doesn't matter how many 1s you multiply, it's going to stay 1. So the exponent doesn't really matter. So I'm just going to get rid of it. It does not matter, so I'm going to get rid of it. And then what's left? Now I have a times 1, but 1 times anything is itself. So a times 1, well, that's just a. So that means we would just get a plus k. The important thing to know is there's no x anymore, right? There's no x anymore. So that means f of x, the function value, or however far, remember that's how far up on the graph you are, is going to be a plain number. So it's never going to change. So that means the graph would be a flat line. That would be a horizontal line, right? Horizontal line, like that. A horizontal line. And how far up or down it would be? How far up would it be? It would be at a plus k. That's where it would be. That's where it would be. Kind of just a specific thing, but it's kind of cool. That B's 1, you get a flat line. Okay, so here's how you are going to graph an exponential function. Okay, so what we wanted to do here was look at all the different pieces of the equation and what do those pieces do. Just to kind of give you a summary, that's what we did on this page. We looked at all the pieces for the big equation and what does each piece do. So here is how you are going to graph an exponential function. Okay, here's the equation again. Okay, and this is the one that we're going to do. We're going to do 2.5 with x plus 2 in the exponent spot minus 3. Okay, so I'm going to put the steps over here on the left side, and then I'm actually going to do those steps over here under the example simultaneously. So I'll say what this first step is and then do the first step. Then we'll talk about the second step and do it. All right. So the first thing you want to do is you want to take the x plus h part, just the exponent, and put it equal to 0 and solve that. So whatever is in the exponent, I'm going to put that equals 0, like this. What's in the exponent spot? X plus 2. So x plus 2 equals 0. There you go. And solve it. Okay, so I get x equals negative 2. Okay, so I solved that. Really easy. That's a really easy step. Okay, number 2, use the numbers that are 1 and 2 away from the x that we found. So we're going to use this x and numbers that are 1 or 2 away from this number and set up a table. So here's my table, and I'm going to put this number that we got in number 1, part 1, step 1. I'm going to take this number and put it right in the middle. Okay, what other x's are we going to use? We're going to go up 2, or we're going to go down 2. So you put this number from step 1, you put that right in the middle, go up 2, and go down 2. And those are the x's that we're going to plug in. Okay, and then so all we would need to do to get, what's the next step? Is we're going to plug in all these x's to get all the y's, or the f of x. Okay, so we're going to take 0 and put it where x is, and do 0 plus 2, and then 2.5 with that exponent, do that, minus 3. So you plug it in, put that number where the x is, plug it in, and get the number. Okay, do your adding, do your exponents, do your subtracting, and then you get your number. Okay, I'm going to do that for all 4 of these. I'm not going to do it by hand because it would take forever, and you don't want to watch that. Here they are. Okay, so when I plug negative 4 in, you get negative 2.84. When you plug in negative 3, you get negative 2.6. Okay, and so on. All I did was take these x's, plug them into the equation to get these numbers. And then the last step, plot the points and draw the curve. Okay, That's all you got to do. We have points, okay? So instead of making it complicated, like you got to remember the main graph and slide it up or all that, you just plug in, get the points, and then just put them on the graph. Take all these points right here, just make dots on the graph, okay? I'm looking for 5 numbers here. I want you to put this one in the middle. From step 1, put that X in the middle, go up 2, go down 2, plug them in. Just get the points, take those points, make dots on the graph, okay? After you make your dots, draw the curve, just like that, okay? That's not too bad. Look at step 1. Step 1 was really easy. Step 2, okay, put that in the middle, fill in the other 4 numbers. Step 3, probably the most work. Just plug them in, and then once you have your numbers, just make your dots on the graph and connect them, and boom, there you go. Okay, all right, one slide to go. So this just to summarize. I'm trying to summarize each and every slide before we keep going. Just to summarize, this is an exact example of how on your homework problems, the exact steps and my example for what you should do on your homework. Okay, how you do these. So just a few tips and tricks. These will be really quick. For exponential functions, the asymptote will always be horizontal. Remember that boundary line, that red one from the second or third slide? The asymptote will always be horizontal, and we'll have an equation that is y equals some number. Anytime you have a horizontal line, all horizontal lines, their equation is y equals a number. That number will always be the same number as whatever number k is. So whatever k is, that's where your asymptote is going to be. Whatever number k is, that's how far up or down your red line would be. And then that means that the range will also be based on whatever number k is and whether a is positive or negative. I can go back over here really quick and just point out that these two come together just to say the equation will be. So if I ask for the equation of the asymptote, you should put y equals and then whatever number is in the k spot. Okay, if I ask for the asymptote equation, you should put y equals and then k is whatever number is in the k spot from the equation. Let me show you what I mean by this a stuff. So if a is positive, then the range is going to be f of x. So I'll always start with f of x for the range. And if a is positive, then it's going to be greater than k, whatever number k is. Obviously the opposite then, if a is negative, then the range is f of x is less than whatever k is. So notice it's always f of x for the range with k, and you just got to look at which way does your sign go. It's for if a is positive, then it's going to be greater than. If a is negative, it's going to be less than, like this. And I put the graphs here to show why that is, right? Because all of our y numbers are above k if the graph goes up. If the graph goes down, then all of our y numbers are below k. And so that's why that is, just so you can see where that's coming from as far as the graph goes. Okay. So that's all I've got. I hope you guys have a good rest of your day. Okay, I know this is kind of strange, just doing it. And I hope your homework goes well. Please remember to email me if you got questions. I'm trying to check my emails as much as I can. Everybody's home life is different, and everybody's got their own challenges. But I'm trying to check my emails as often as I can. Please, definitely, absolutely, if you have a question, email me. Okay, have a good one.